Hello all and welcome back. Today we're going to look at 3.2, which is solving with square roots. Now, you all in your previous math lives have definitely done this before, so a lot of today is going to be a refresher for you. We are going to throw that idea of I in there, so we have a few new things to learn, but this is probably going to feel very, very familiar at first. Let's go ahead and start by writing down the steps that we're going to follow to solve with square roots. The very first step is we're going to isolate x squared. That word isolate just means get by itself. So we're going to move anything that's with x squared to get it all alone. The second step is we take the square root of both sides. That allows us to cancel out the square that's on our x so that we can solve and we have x equals something. The last little note is just don't forget plus minus. Anytime we add a square root into a problem, it wasn't originally there, we have to put that plus minus in front. Let's go ahead, let's work through a few examples together for this lesson. All right, number one, we're solving 3x squared equals 27. Again, that first step is I need to isolate x squared. I need to get it all by itself. The thing with x squared is the 3. These are being multiplied right now, so the opposite of multiplication is division. And I'm going to start by dividing both sides by 3. They're going to cancel on the left, which leaves me x squared. And 27 divided by 3 is 9. Now that my first step is done and I've isolated x squared, now I'm going to take the square root of both sides to solve for x. Whenever we square root a square, they cancel and I'm left with just x on this side. The square root of 9 I know is 3, and again that note was don't forget plus minus. So anytime we add that square root in, I need plus minus in front. So x equals positive 3 or negative 3. Both would make this equation true. Let's go ahead and look at another one. 2/3 x squared equals 18. Same thing, so I need to isolate x squared, and I wanted to remind us how we get rid of fractions. So instead of multiplying by a fraction, and we would divide that out, but instead of dividing, I can multiply by the reciprocal. So the reciprocal of 2/3 is 3 over 2, and I'm going to multiply by 3 over 2 on both sides. These are going to cancel each other out on this side, so I'm left with just x squared. And then 18 times 3 over 2, you could type in your calculator. You could do this in your head if you know how to do that. But 18 times 3 over 2 is 27. I did isolate x squared. So now I can take the square root of both sides. Again, whenever I square root a square, those cancel. I'm left with just x. And then the square root of 27, if you all will pause and type that in your calculator that you have in class with you, your Casio calculators do simplify radicals for you. So if you type in the square root of 27, you're going to get 3 square root 3 back. If you're not sure how to type a square root in, you hit Shift, the yellow button, and then x squared. So Shift x squared will allow you to type that square root in, and you should get 3 square root 3 back. If you don't, then check in with your teacher and fix some issues with your calculators. And the last thing is because we added that square root in, it was not there originally, I do need plus minus in the front. So positive 3 radical 3 or negative 3 radical 3 would both make this equation true. All right, number 3, actually cover number 4. So number 3, very similar. There's now a plus sign in the middle. Just wanted to remind us that it's not really anything different. To isolate x squared, I need to move that 25. These are not being multiplied this time, these are being added. And because my 25 is positive, I'm going to subtract it off to the other side. 25s are going to cancel out, which leaves me x squared. And then 169 minus 25 is 144. I've isolated x squared, so now I can take my square root. That square root is going to cancel out my square, which leaves me x on the left. And the square root of 144, I know, is 12. Because I added a square root in, I'm going to put plus minus in front of it, and that is my final answer. Positive 12 or negative 12 would both make this equation true. All right, last one of these, number 4, I want you to try. So take a quick second, try that one, pause the video, and then hit play whenever you're finished. All right, so number 4 is very similar to number 3. I'm going to start by subtracting 16, which leaves me with 9. We take those square roots, and you should end up with x equals plus minus 3. All right, let's look at what happens whenever they're a little bit more difficult. So this next number 1, I have some more things going on here. I don't just have one term, I have 2, and so I need to isolate that x squared. Remember, whenever we solve an equation, I work in reverse order of operations. So I'm going to start by moving things that are being added or subtracted, which in this case is that minus 2. The opposite of subtracting 2 is to add 2. So I'm going to add 2 to both sides. Those are going to cancel out here, which leaves me negative 12x squared equals 34 plus 2 is 36. Now I'm still trying to isolate x squared. I cannot take a square root yet because that negative 12 is living in the front. So before I square root, I'm going to divide both sides by negative 12. My negative 12s cancel. They leave me x squared on the left. And 36 divided by negative 12 is negative 3. Now that x squared is by itself, I've isolated it. I can now take the square root of both sides. Whenever I square root that square, they cancel. I'm left with just x. And we have a few things to remember on this one from 3.1. The first thing, right, is remember that I is the square root of negative 1. So because I have that negative underneath there, that's going to pop out as an I. I don't know the square root of 3. That's not a nice perfect square. So we're going to leave that as square root of 3. And then because we put the square root in, don't forget we do still need that plus minus, even with imaginary solutions. Again, a little bit weirder on this one, kind of combining 3.1 and 3.2. Couple more examples left for 3.2. Let's go ahead and look at number 2. Number 2 is 4 plus 3x squared equals 12 plus x squared. And I'm going to start by combining my x squareds together. I have x squared on both sides. I don't want that. I'm going to move them together. Now, I'm in the habit of moving things so that x squared stays positive just because I don't like dividing by negative numbers. It doesn't matter what order you move in. You can combine pieces in any order that you would like, but I'm going to subtract this x squared over to this side. My 4 didn't change. 3x squared minus 1x squared is 2x squared. My 12 didn't change, and my positive and negative x squareds canceled out. Now I'm again still trying to isolate x squared. So I'm going to move pieces that are being added or subtracted, which in this case is the 4. It is positive, so I'm going to subtract 4 on both sides. That gives me 2x squared equals 12 minus 4, which is 8. From here, I still can't take a square root yet. I need to isolate x squared. To do that, I'm going to divide both sides by 2. So x squared equals 4. And finally, now that x squared is all by itself, now I can take the square root of both sides. When I square root that square, they cancel. I'm left with just x. And then the square root of 4 is 2. Because we added the square root in, I do need that plus minus in front. So positive 2 or negative 2 would both satisfy this equation. Let's put all of this stuff together. The last example, number 3, I want you to try, pause the video, and then hit play whenever you're ready to check your answer. All right, let's check in. Again, I'm going to get those x squareds together. If you started off with something different, that's okay. Give me just a second and we'll make sure we end up at the same place. 3x squared minus x squared gives me 2x squared. And then I'm going to subtract this 15 over here, which would give me negative 10 equals 2x squared. Now, if you didn't end up here, maybe you moved pieces a little bit differently, that's okay. You should still have negative 10 equals positive 2x squared. Or, depending on the order, you may end up with positive 10 equals negative 2x squared. Both of those are correct. So just double check that you have one of those two options. From here, I'm going to divide both sides by 2. Negative 10 divided by 2 is negative 5. Those 2's cancel, leave me x squared. Now that I have x squared all by itself, I'm going to go ahead and square root both sides. That square root cancels out my square. I'm in the habit of always writing x on the left, and it doesn't matter in this case. My negative becomes an I. I don't know the square root of 5, so I'm going to leave that as square root of 5. And then because we added the square root in, I do need that plus minus in front. Hopefully these went okay for you. We do have 2 quick geometry examples to look at, just as an application of solving with square roots. So we're going to look at 2 triangles here to solve for some side lengths. Now, we probably remember whenever we have a right triangle, we can use something called the Pythagorean theorem to solve for a missing side. That Pythagorean theorem is a squared plus b squared equals c squared. And remember, a and b are the legs of your triangle, and c is your hypotenuse. It's the one across from your right angle. We're going to go ahead and try to solve for c. A and b are the legs. It doesn't matter which one you make which. I just pick whatever the first one is as A and the second one is B, and that's totally fine. So my A in this case is 6, my B is 4, and I don't know C, that's my X. I'm going to work my way through and solve for X, and here we go. 6 squared is 36, and 4 squared is 16. When I combine those together, 36 plus 16 is 52. X squared is by itself, so I can go ahead and take the square root of both sides. Now on these ones, the square root of 52 isn't a nice pretty number. So it says then write approximate lengths correct to the nearest 0.01 centimeter. So I want 2 decimal places on these. The square root of 52 would be my exact answer. And if I type that in my Casio calculator, there is a button to change from a fraction to decimal. And so that F arrow D button will change this to a decimal for you. And I end up with 7.21. My units here are centimeters. Now let's think about on all of the problems we've done up to this point, we put a plus minus in front. Whenever you have word problems or things in geometry, the negative stuff doesn't always make sense. Because we're talking about the side length of a triangle, I don't care about the negative value. I only want the positive value. Let's go ahead, last example. Let's label this triangle. I got my a squared plus b squared equals c squared. I want to remind you that c is always across from your right angle, A and B. You can label them in any order. You try to find that missing side C, pause the video, and then whenever you think you have it, go ahead and hit play. All right, let's label. I made 10A and 3B, so that would give me 10 squared plus 3 squared equals x squared. 10 squared is 100, 3 squared is 9, and if I add those together, I get 109. To solve for x, I need to get rid of the square, so I'm going to square root both sides. My exact answer would be the square root of 109. I don't really know what that means in terms of triangle side length, so if I type that in my calculator, use my F arrow D button, I should get 10.44 centimeters. All right, that's everything for 3.2. You should be able to complete your assignment now. If you have any additional questions, please reach out to your teacher for help.